We'll think about a question from application of derivatives, maxima minima application question. A point on the hypotenuse of a right triangle is at distances A and B from the sides of the triangle. Show that the minimum length of the hypotenuse is A to the power 2 by 3 plus B to the power 2 by 3, the whole to the power 3 by 2. In application questions of maxima minima, we need to follow the following steps properly. Step number 1, find out what is to be maximized or minimized. That is what we call as a function of the maxima minimum question. Find the function. Here it is the hypotenuse is the function. So I need to express the hypotenuse. Second thing that you should do is convert that function into single variable. Third thing, when it is in single variable, third thing that you should do is you differentiate it. Fourth thing, you equate to 0. Then with the value that you get, you use this in the function to get the proper answer. Then the last thing is you should differentiate that function again. Second derivative you need to find. If second derivative is negative, it's maxima. And if its second derivative is positive, then it is maxima. So here we have to make the second derivative positive. Okay, let us look at the function first. They said about a right angle triangle. Let me draw a right angle triangle. They said a point on the right angle triangle is at distances A and B from the sides. Let me choose any point, this point P. The distances means perpendicular distance. This let me take as A distance. This distance let me take as B distance. So A distance and B distance. For convenience, let me name this triangle as ABC. And let me choose this point as some S. So what is our concern is the hypotenuse AC. AC means nothing but AP plus PC. This is what is to be minimized. With this, when it is minimum, you have to prove that this is the length of the hypotenuse. Okay. So first we will write this function in single variable. Here it's only a representation. I need to convert in terms of A and B. How is that possible? You should understand this BC and SP are parallel because both are perpendicular to this AB. Then let me choose this angle as theta. If this is theta, this is also theta. Now what I do is this A I want to get with the hypotenuse. So I will consider theta's opposite side is A. Sin theta means opposite side by hypotenuse. So let me choose sin theta. Sin theta is opposite side A by hypotenuse is PC. From here you can write PC is equal to A by sin theta. That means A cosec theta. Similarly, I can take from here for theta, this is adjacent side. For this theta, this B is adjacent side. To bring B into the picture, I will write cos theta. Cos theta is adjacent side, B by what? AP. From here I get AP is B by cos theta or B sec theta. Now I will write it here, AP as B sec theta plus PC as A cosec theta. So the first and second step over, I wrote the function, I converted it into single variable. Here what is the variable? Theta is the only variable. Now the third step, I will differentiate. So d of AC, derivative of AC with respect to theta, that is equal to B sec theta derivative is sec theta tan theta plus A minus cosec theta cot theta. The next step we will differentiate the derivative will equate to 0. So I will get B sec theta tan theta is equal to, when you equate to 0, this minus I will take to that side, A cosec theta cot theta. Once again, this whole thing equal to 0 means this I can take to the other side, it will come. Now this is B, this is 1 by cos, sin by cos. So only sin will be numerator by cos square theta. Similarly here A 1 by sin, cos by sin. So only cos will be numerator by sin theta, sin square theta. When you cross multiply, you will get a B sin cube theta is equal to A cos cube theta. Okay, from here I can write cos cube you divide here. Tan cube theta is equal to a by b to the power 1 by 3. Oh, sorry. A by b. So next step we will write tan theta is equal to a power 1 by 3 by b power 1 by 3. Now what is the use of this? This is the derivative equating to this is the critical point. This why do we need? We are going to use this in this function AC and get the answer. So this we believe this is going to be the minimum. That we will have to do as a second part to prove that the second derivative is negative. So what I do right now is let me erase this part. This I don't want anymore. What I do is I will write here AC, the hypotenuse. AC is equal to what? This B sec theta plus A cosec theta. Now I want sec theta value from tan theta. How is that possible? You draw a right triangle. Tan theta is opposite side by adjacent side. Let me consider this as theta. Opposite side is A power 1 by 3. Adjacent side is B power 1 by 3. I want to know what is hypotenuse. Hypotenuse is the square root of the squares of the other two sides. So square root of square of A power 1 by 3 is A power 2 by 3. Square of this is B power 2 by 3. Now I will write from here B sec theta. Sec theta is adjacent side by hypotenuse. So B power, hypotenuse by adjacent side. Root of A power 2 by 3 plus B power 2 by 3 by B power 1 by 3 plus, now A cosec theta is hypotenuse by opposite side, A power 2 by 3 plus B power 2 by 3 by A power 1 by 3. Let me choose this A root of A power 2 by 3 plus B power 2 by 3 common factor. What is left? B by B power 1 by 3. When you divide B by B power 1 by 3, 1 minus 1 by 3 is 2 by 3. Plus this A by A power 1 by 3, when you A power 1 minus 1 by 3 is A power 2 by 3. Now children look, this both bases are same. This one's power is 1 by 2. Root means 1 by 2. This power is 1. 1 plus 1 by 2 is 3 by 2. So this is A power 2 by 3 plus B power 2 by 3 to the power 3 by 2. So we proved what they asked. We proved that the hypotenuse is this. Now one more small thing is there, one mark left. That is to prove the second derivative of the function is positive. Why positive? Positive only we can say it's minimum. So that part I am going to do. So I am going to differentiate this thing once again. What? This dc by d theta. I will differentiate it again. So that you have to do it. So d square AC of d theta square. Okay. So we will find the next second derivative. So with this will become b into this we will have to use product rule. Sec theta derivative sec theta tan theta into second function tan theta plus sec theta into tan theta derivative c square theta over minus a cosec theta is minus cosec theta cot theta, then into cot theta plus cosec theta into minus cosec square theta, cot theta derivatives. Okay children, now what I want to tell is I am not completing this one. This minus if you multiply inside, this will become plus. That minus into this minus also this will be plus. That means all these functions are, this is already positive. All these functions are positive. All the functions, this negative also will get converted to positive. So ultimately the whole thing is greater than 0. Why? This trigonometry theta is an acute angle. When theta is acute angle, all the trigonometry functions are positive. Therefore, A and B are length, they are also positive. So therefore, this all positive. Therefore, you can say what our function is minimum. So we conclude it like that. Okay, have a look at it and try to do it by yourself once. Then it will come.